Hi there. So we are going to be going through a lesson today. This is one of the more difficult lessons in the course, actually, but I'm going to do my best as I can. So it's going to be independent and dependent events. So just as a reminder, independent events are events that don't affect each other, and dependent events are ones where one event depends on the probability of one event depends on the results of a different event. So what we have is, for independent events, so if the events are independent, then the probability of A and B is the probability of A times the probability of B. For dependent events, the probability of both events happening is something else. And we'll get to what that something else is eventually. So, example number 1. Let's say we roll, so we roll a 6-sided die once. What is the probability of rolling a 3? So if we roll a 6-sided die once, what's the probability of rolling a 3? 2d6. So if we roll a 6-sided die twice, what's the probability of rolling a 3 both times? So what we have here is we have two events. So the first one is going to be, A is going to be roll a 3 the first time, and B roll a 3 the second time. Now I'm going to argue that these are independent events. So rolling a 3 the second time has no bearing on whether we're going to roll a 3 the first time. I mean, the other way around, right? Whether or not we roll the 3 the first time has no bearing on whether or not we roll a 3 the second time. So these are independent events. Now the probability of rolling a 3 the first time, it's a 6-sided die, so it's going to be 1 out of 6. The probability of rolling it on the second one is similarly 1 out of 6. Because they're independent events, the probability of A and B is going to be the probability of A times the probability of B, which is 1 over 6 times 1 over 6, which is 1 over 36. Which is not very thrilling, but it's good enough. Next example. So there is a 70% probability that Stan will see Wendy. %, probability Stan has gum in his pocket. So there's a 70% probability that, I had some arrows here, they kind of fell off the edge of the screen. So 40% probability that Stan has gum in his pocket. And so the two questions I'm going to ask are, what is the probability that Stan sees Wendy and has gum? B, what is the probability Stan sees Wendy and does not have gum? I would recommend writing these down. You don't want to have to watch through the whole video to get the questions again. But we're not in class, so you can do what you want, and I will never know otherwise. So I'm going to argue that these are independent events. Whether or not Stan has gum in his pocket is independent of whether or not he sees Wendy. So we're going to define our events here. Again, I'm going to say A is sees Wendy, and B is that he has gum in his pocket. So the probability of A, the probability he sees Wendy is 0.7. The probability that he has gum in his pocket is going to be 0.4. Now we're going to say, what is the probability that of not A? So in this case, the probability of not A would be that he does not see Wendy. So the probability that he does not see Wendy, if there's a 70% chance that he sees Wendy, there's a 30% chance that he does not see Wendy. Similarly, the probability that he does not have gum is going to be 60%. So the answers to the questions now, what's the probability that Stan sees Wendy and has gum? So what I'm looking for is the probability of A and B, which is going to be, because they're independent, the probability of A times the probability of B, which would be 0.7 times 0.4, which I think is 28%. It's going to be a little trickier now. Usually I rely on the class to double check my numbers. I'll have to make sure they're actually right from now on. So the probability of, so what we want is we want Stan sees Wendy and does not have gum. So the probability that he sees Wendy and does not have gum, so what the probability of A and not B, which is going to be, again, because they're independent, the probability of A times the probability of not B, which is 0.7 times 0.6, which is 42%. And I didn't actually ask it a question, but I could have, for example, have said, what's the probability that he doesn't see Wendy and does not have gum? So the probability of no Wendy and no gum would be 0.3 times 0.6, which would be 18%. All right, and so that's that for independent. So I'm going to pause that video here so that if I screw up the next example, I won't have to redo that entire thing.